Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0977, indicates an issue specifically with the shift solenoid valve B in the Honda CRV models from 2011 to 2016. The shift solenoid valve B is responsible for controlling the transfer of transmission fluid in the automatic transmission system, affecting gear shifts. When this valve experiences an electrical circuit problem, it triggers the DTC P0977 due to an open circuit, which means that the valve is not operating as intended. Typically, this issue cannot be attributed to mechanical problems within the transmission itself. Therefore, the diagnostic process focuses primarily on the electrical components that interact with shift solenoid valve B. To effectively retain diagnostic accuracy, it is crucial to capture any freeze frame data and review it alongside other onboard snapshots using the HDS before initiating any troubleshooting activities. This will ensure a comprehensive understanding of the parameters affecting the vehicle's performance at the time of the error. The shift solenoid valve B is a key component in the automatic transmission system of the Honda CRV, functioning to control fluid flow and hydraulic pressure for gear shifting. Located within the transmission assembly, it influences the engagement of various gears by managing the application of hydraulic pressure. This solenoid is connected electronically to the powertrain control module, PCM, which monitors and commands its operation based on real-time driving conditions. The PCM is essentially the vehicle's brain, regulating engine and transmission functions to enhance performance and efficiency. Additionally, proper connectivity through the associated wiring harnesses is essential for the solenoid's operation. An open circuit indicates interruptions in this electronic communication pathway, which underscores the electrical nature of the problem indicated by DTC P0977. There are several possible causes for the occurrence of DTC P0977, which primarily relate to electrical issues rather than mechanical failures. One main cause is a fault within the electrical circuit that connects the shift solenoid valve B to the PCM, potentially due to damaged wiring or poor connections. Such faults can disrupt the communication needed for the solenoid to operate correctly. Another possibility is a malfunctioning shift solenoid valve B itself, which may not respond correctly to commands from the PCM due to internal failure. Additionally, issues within the PCM, such as outdated software or component failure, could also present this trouble code. Understanding these potential causes is essential for troubleshooting and effectively resolving the problem. When DTC P0977 is activated, drivers might experience several symptoms associated with transmission performance issues. One such symptom is erratic shifting, which occurs when the vehicle fails to shift smoothly or skips gears during operation. This erratic behavior can result in reduced power during acceleration, as the engine struggles to engage the correct gear for performance. Additionally, drivers may notice that the vehicle's transmission operates less efficiently, leading to overheating, which can result from improper fluid flow regulated by the malfunctioning shift solenoid valve B. Furthermore, the malfunction indicator light, MIL, commonly known as the check engine light, will likely be illuminated on the dashboard, prompting further investigation into the vehicle's diagnostic codes. The first step in troubleshooting DTC P0977 involves verifying the initial problem indicated by the Diagnostic Trouble Code. Begin by turning the ignition switch to the on position, which powers the vehicle's electrical systems without starting the engine. Next, clear any existing DTCs using the Honda Diagnostic System, HDS, which is the specialized tool for retrieving and clearing codes. After clearing the codes, perform a test drive through the vehicle's range from first to third gear, ensuring to operate in third gear for at least 1 second. This driving pattern helps replicate conditions under which the issue might occur and allows the HDS to monitor for any new DTCs generated during this operation. After the test drive, check the vehicle's DTCs again using the HDS to determine if P0977 reappears, indicating the failure condition has been confirmed. In the second troubleshooting step, the focus shifts to evaluating the operation of shift solenoid valve B directly. Using the HDS, select the shift solenoid valve B option from the miscellaneous test menu. Engage the solenoid by activating the test and listen closely for any audible clicking sounds. If a clicking sound is heard, it confirms that the shift solenoid valve B is operational, indicating the mechanism itself is functioning correctly. Should the clicking sound be absent, it signifies a potential issue within the solenoid or its associated wiring, prompting the technician to proceed to the next troubleshooting step for further investigation. The third step in the troubleshooting process entails a subsequent verification through another test drive. Similar to the previous driving patterns, drive the vehicle through first to third gears again, ensuring the vehicle is operated smoothly with transitions between gears. While performing this test drive, closely monitor the onboard diagnostics (OBD) status displayed in the DTCs menu of the HDS. This monitoring provides insight into whether DTC P0977 is still an active issue. If the HDS indicates that the status is failed, it confirms that the fault persists, thus necessitating further examination. Conversely, if the HDS indicates passed, it suggests there may be only an intermittent issue, or the system is functioning correctly at that moment. In step 4, begin by turning the ignition switch to the lock position to ensure no electrical components are active during testing. Next, utilize the HDS to jump the SCS service check connector line, which is a necessary step to bypass the onboard system for testing purposes. After jumping the SCS line, disconnect the PCM connector B, which contains multiple wires connecting to the powertrain control module. With the connector removed, proceed to measure the electrical resistance between specific test points on the PCM connector and body ground. The expected resistance range is between 13.8 to 17.1 ohms. Should the resistance fall within this range, it verifies that the shift solenoid valve B is functioning correctly. If the reading is outside this range, it indicates a potential failure, warranting further investigation. The fifth step involves examining the wiring specifically associated with the shift solenoid. Start by disconnecting the shift solenoid wire harness 8P connector, which connects the solenoid to the vehicle's electrical system. Following this disconnection, perform a continuity test between two specific test points. You will need to assess the path between the white wire at the shift solenoid harness and the corresponding pin at PCM connector B. The vehicle must be in the ignition lock position during this process. If continuity is confirmed, it indicates that the wiring is intact and the shift harness branch, SHB, is functioning correctly. Conversely, if there is no continuity, an open circuit exists in the SHB wiring, necessitating repair to ensure proper function of the shift solenoid. The sixth troubleshooting step focuses on the integrity of the shift solenoid wire harness. Begin by removing the shift solenoid wire harness to gain access to the necessary connections. Once removed, conduct a continuity test between the shift solenoid valve B1P connector and the shift solenoid wire harness 7P connector. This test is crucial to confirming that there is an uninterrupted path for electrical signals between the solenoid components. Again, ensure the ignition is in the lock position during this test to avoid any electrical interference. If continuity is confirmed without issue, it indicates the wire harness is functioning correctly. However, if continuity is missing, it signifies a need for repair or replacement of the wiring harness to restore proper functionality of the transmission shift mechanism. The final repair verification process is essential to ensure that all issues related to DTC P0977 have been adequately addressed. Start by reconnecting all previously disconnected connectors, ensuring proper seating and secure connections to restore functionality. Next, turn the ignition switch to the on position and utilize the HDS to clear any remaining DTCs that may still be stored in the system. Once cleared, start the engine with the shift lever set to P for park and allow it to idle for at least 1 second. Following this idle period, perform another test drive, repeating the action of moving through the gears as done previously. Finally, monitor the OBD status for P0977 within the HDS. A passed result indicates that the troubleshooting and any repairs have been successful, while a failed or not completed status suggests further investigation is necessary. Preventive maintenance is key to avoiding future occurrences of DTC P0977 and ensuring the longevity of the vehicle's transmission system. Regular inspections of wiring and electrical components associated with the shift solenoid can help identify potential issues before they lead to failure. Additionally, monitoring transmission fluid levels and condition is critical, as proper fluid flow is essential for shift solenoid functionality. It is also advisable to check for any updates or software patches for the PCM and apply them as necessary to keep the vehicle's computer system functioning optimally. Taking these preventive measures can significantly reduce the likelihood of encountering similar DTCs in the future. In summary, understanding DTC P0977 is critical for effective troubleshooting and repair of shift solenoid valve B issues in Honda CRV models from 2011 to 2016. By following systematic checks to identify whether the problem lies within the solenoid, the wiring harness, or the powertrain control module (PCM), technicians can accurately diagnose and rectify the failure, ensuring the functionality of electronic components and connections is paramount for the vehicle's transmission performance. Additionally, adopting preventive strategies such as routine inspections and software updates for the PCM can mitigate the risk of future DTC occurrences. A comprehensive approach that encompasses both immediate troubleshooting and long-term maintenance will lead to a reliable vehicle operation and enhanced driver satisfaction. Please like and subscribe to the channel. See you next time.